Good morning, everyone. A warm welcome for today's guest lecture on Science in Antarctica by Dr. Felix Bast. I'm Dr. Kim Rodriguez, Assistant Professor, Department of Botany, Carmel College of Arts, Science and Commerce for Women, Nuvengoa. For today's session, we have amongst us faculty members of the Department of Botany and undergraduate students of Botany of first year, second year, and third year classes. A few lines of introduction about our guest speaker, Dr. Felix Bast. Dr. Felix is an author, public educator, and associate professor and head, Department of Botany, Central University of Punjab, Batinda. A BSc Gold medalist from Kannur University, Kerala, he completed MSc from University of Madras. Later on, he pursued his PhD from Kochi University, Japan, wherein he was selected under the prestigious academic scholarship MEXT. Dr. Felix Bast has served as an invited in-residence intern with President of India as an inspired teacher for 1 week at Rashtrapati Bhavan, New Delhi. He has been a recipient of INSA Inspire Faculty Award and Teaching Innovator Award, Government of India. He is also a member of National COVID-19 Task Force by INSA and Indian Scientists' Response to COVID-19. Dr. Bast has received a number of international recognitions and underwent training from a number of institutions worldwide. His major research contributions include the discovery of 7 new species of marine algae and moss from the Indian coast and Antarctica, the discovery of endophytic algae from the Indian Ocean for the first time, and demystification of blood rain phenomenon. Dr. Bast is a known science communicator in India through his writings, outreach talks, and YouTube videos. His talk has been featured in numerous media, including All India Radio, Rajya Sabha TV, and TEDx. Dr. Bast is an expert panelist at International Science Council, Paris. He served as an elected National Core Committee member representing biology and medicine at Indian National Young Academy of Sciences. He founded Young Academy of India and initiated its integral program, Mentex. Dr. Bast is also involved with SWAYAM as a course coordinator. In addition, he is an avid cyclist, a runner, a frequent blood donor, and an advocate of zero waste and low carbon footprint lifestyle. Dr. Felix Bast was part of Ministry of Earth Sciences, Indian Scientific Expedition to Antarctica, 36 delegation as expedition scientist, and stayed at India's research stations, Bharti and Maitri. In today's lecture, Dr. Bast will share his research experience. It is an honor and a privilege for us, sir, to have you with us today. Over to you, sir.
Yeah, thank you so much, Dr. Kim, for having me here. And it's my privilege to spend this morning with all of you. I can see that there are a lot of faculty members from your college, as well as many of the students, especially the BSc and MSc students like us, of botany. Though I'm not really a botanist, right now I'm heading the Department of Botany here. So my specialization is on algae, marine plants, algae. So algae classification is what I work on. So now let me share my screen. I came here with a small presentation. And so I want to make it as interactive as possible. I can see around 41 participants here, 40 besides me. So it is a small gathering. And instead of having a dedicated Q&A session at the end, you are welcome to interrupt me at any point. Okay. So I'm just combining many things, my experience in Antarctica, what kind of things that I do, and also, my own inspiration to take up this kind of exploratory research on basic sciences and what made me who I am right now, so my own life also. I'll just share a little bit. So, so I'm basically from a place called, the Central University of Punjab here in Punjab. I'm talking to you from a small town called Batinda. It's actually a village near Batinda. Okay, so I've been working here for 10 years. It's been 11 years, I would say, 2010 onwards. And before that, I was in Japan, as Dr. Kim told you about. And thanks for the first of all, thanks Dr. Kim for inviting me for this gathering here. And I was also privileged to be a part of this Indian Antarctic mission to Antarctica. And guess what? We started our journey from Goa. So there is an institute there. I don't know how many of you know it. NCPOR, that is called National Center for Antarctic, the Polar and Ocean Research. Earlier, it used to be called NCAOR, National Center for Antarctic and Ocean Research. Now it is called Polar and Ocean Research because India have got two Antarctic polar stations, right? One in Antarctica and one is in Arctic as well, though it is not in international territory. Arctic station Himadri is actually part of the Norway, so it is in the Norway, but Antarctic station is actually ours. We have two stations in Antarctica, right? So before going to Antarctica, friends, I went to so many places, 22 countries, I would say, including not in, including Antarctica. So yeah, the reason why I want to show you this is that I went to all these places, although I was born in a very middle class family. My father was a school teacher and my mother was a nurse, and the first international trip which I took is from Bombay. I went all the way to Tokyo with the government scholarship. I got this prestigious government of Japan scholarship, MEXT. It's called MEXT. Every year 30 Indians do get this scholarship, and nothing prevents you from applying. If you're a student and if you want to go abroad for your PhD or even MSc, do try. There are several such government scholarship scheme in which you don't even have to write GRE or TOEFL or IELTS, nothing, just a plain paper application during those days. And now it is just, you know, just a online application, and then the Ministry of Education will call you for an interview if you're shortlisted. And then again, after interview, they will recommend your name. They will nominate your name to foreign embassies. And finally, you will be getting, the invitation letter from the foreign embassy. So many of us don't know even the existence of all these programs, and we have this we have this mindset that a foreign education, a foreign degree is so expensive and you need to be really rich, otherwise we cannot afford it. That is incorrect. So even if you don't have any bank balance, you can go there. It's just a matter of spending a few hours on crafting a fantastic application. you know so in 2016, just before I went to Antarctica, I went to a place called Norway. It's one of the very beautiful country I've ever been to. All the Scandinavian countries are beautiful, but exceptionally beauty is in Norway, especially Norwegian fjords. And I went to Tromsø and Oslo in 2016, and it's very interesting in Tromsø. I can share with you two experiences. One experience is that over there, the sunset was around 11:30 in the night, midnight sunset, and then sunrise 12:30 again in the midnight. So the night is just for 1 hour, 23 hours of sunlight and just 1 hour of darkness. And why is it so? It's so bizarre, isn't it? It's because of polar region. Tromsø is inside the Arctic Circle. Just at the Arctic Circle, at the edge of it is the Tromsø. Second experience I had in Tromsø is that I went in a ferry to a small island, Lofoten Islands. And on my way to Lofoten, I saw that mosquitoes there outside the ferry, the glass window. I saw mosquitoes. I was super surprised because it's super cold place. It's inside the Arctic Circle. And how could the mosquitoes live over there? So I asked the co-passengers of that ferry, and they said that it's new there. It's been only last 10 years you can see mosquitoes in Lofoten. So things are changing. The globe is changing, friends. Globe is warming. These are all repercussions of the global warming. Species migrations do differ, right? So the species early days, warm habitat species cannot migrate to cold places. But now the cold places are getting warmer. Such migrations are possible. You don't have to go all that far to Norway to experience it. Here also, very near to my place where I live, is Himalayas. If you go to Shimla, for example, 10 years ago, there is no mosquito in Shimla. Now you can see mosquitoes in Shimla or any of the high altitude regions. So all because of the global warming, friends. And then I went to Oslo. Oslo is basically the the capital of the Norway. It's a very famous place of the Nobel Prize as well. Stockholm and Oslo. Peace is actually given in Oslo. And I went to a museum there called Fram Museum. So the moment I heard this name Fram, it's something nostalgic for me because as a young boy in school days, I read a very beautiful book in Malayalam. I'm from Kerala, and my entire education was in Malayalam medium in government schools. You know, but in Kerala there is a very good movement of popularization of science, and that is my inspiration to science communication. Why I am also a science communicator in part. You know, so yes, so science communication is very strong in Kerala. That many of the international bestsellers, the book, gets translated into Malayalam. And I was so fortunate that I read books like Cosmos by Carl Sagan in Malayalam when I was like in seventh grade. And one of the book which I read by this in Malayalam is called Fram. And what is Fram, by the way? Fram is the name of a ship, very famous ship in the world, perhaps. Well, people know about Titanic, but how many of you know about Fram? So Fram is a wooden schooner. So it's completely wooden shape, and it's built in Norway. Norway is a country known for its maritime capabilities and ship making, And this is a very famous ship because this is a ship that Norwegian explorer called Roald Amundsen took on his maiden voyage to Antarctica. So he's the first person ever in the history of Earth, history of world, to set foot on the South Pole. So he took this ship. So the whole ship is a museum now. You can get in, you can take photograph, you don't have to remove the shoes. It's very different, the system in the Europe or elsewhere, if you compare that with the Indian system. And it's the curation is first class. So it is preserved as it is, So yeah, that is another of my inspiration to try for this Indian Antarctic mission. Then, the Antarctica is very different place, friends. It remained unknown to the humanity until 19th century, So before the Amundsen set forth in South Pole, and a little bit before that is the Russian explorers, who actually found the Antarctica in the late 19th century, early 19th century. So it is, do you know how many of you know that the Neptune, the planet Neptune we discovered earlier than Antarctica. So we knew Neptune much early than we knew that there is a continent called Antarctica. So the name Antarctica is actually anti-Arctic. So philosophers predicted that there is an Arctic, there is a landmass on the northern hemisphere, and you need to have a counterbalancing landmass in the southern hemisphere too. So that was like a prediction, Aristotelian prediction. And that is exactly what we found, that there is a landmass called Antarctica. So, that is why it's called Antarctica. And there is no mention of it in any of the religious book. Of course, there is a mention of moon, sun, all the constellation, because everything you can see by your naked eye, isn't it? But Antarctica, you cannot see it. You need to go over there. And this is the only continent without any religion. The continent is governed by Antarctic Treaty System, and ATS prevents the use of this continent for anything except scientific exploration. Not even mining. Mining is disallowed. Military expansion is disallowed, and the entire continent is an international space for researchers like us. We can do the research over there. It's something like International Space Center, you know and there is no border, and there is no war, no conflict, no murder yet in Antarctica. And it's also the most pristine places on planet Earth because the pollution is very, very less there, you know so yes, so I applied for it. So the application, if you're interested to apply for this Indian Antarctic mission, every year there is almost 100 people go, and out of which around 30 are scientists, and the mission is called Indian Scientific Exploration to Antarctica, and the rest 70 are supporting staff to help us. For example, we have Jawans from BSF to carry our stuff and to help us, logistically when we do field trips. We also have doctors, we also have nurses and engineers, and all those cook, for example, for our food. Of course, the cook is the one who is responsible for the kitchen and cooking, but it's not that everything is his job or her job, and it's everybody. It's a teamwork, friends. That is the beauty of this Antarctic mission, you know. And also we had the diesel mechanic, probably the most important, the most crucial person in the trip, because this mechanic is responsible for maintaining warmth in the Antarctic stations. You know, without warmth, everybody will be frozen to death. In Antarctica, the temperature is minus 79 degrees Celsius. You know, very, very cold. Then, well, I applied for this proposal to the Ministry of Education. What I want to do in Antarctica, what kind of research I would like to do. Then they shortlisted, they called me for an interview. And after that, in September 2016, I got a call letter that you have to undergo a complete medical checkup in AIMS in Delhi. And this is not like I was expecting. It's something like a normal blood check for HIV and hepatitis, all those things, or diabetes and all. No, it is a complete comprehensive check for almost 1 week. I was so surprised. Like, even there is a TMT, treadmill stress test, echocardiogram, and liver CT. So every single test. And if you are a prospective applicant, of course, the students can go. The PhD students can go in part of this in the Antarctic mission. If you are if you really want to go to Antarctica, then my two advice is that, one, never start smoking. If you're a smoker, then the test can easily detect it, and you cannot go there, because there is a test called Cotinine, very cheap test, only 10 rupees. It's part of any medical insurance you take, or a term insurance plan, life insurance. This test is a biochemical test. Cotinine is a biomarker in the urine, and it will be revealed if the test is positive. That means that you have smoked at least one cigarette for the last 2 years. That's very accurate. Second, do not drink alcohol. So if you do drink alcohol, there are traces of the fatty liver problem in the city of the liver, and then you will not be declared medically fit. So many of my colleagues failed in either of these two tests. So AIMS, that is really important. And you might wonder why this so much tough medical test in Antarctica, because of the low proximity to any of the major civilization. In Antarctica, the nearest city is Auckland of New Zealand. And guess what? It's around 4,000 kilometers. It's not easy to travel. In case you are in Antarctica, you got like a mild heart attack, chances are high that you cannot be, you cannot be saved. Uh, because the medical facility, even though we have doctors, facilities are highly constrained. We really didn't have any facility in the medical center except few tablets here and there, not even an X-ray machine. So what doctors can do, isn't it? So that is why it's really important. Second step of this trip is, there is a 3 weeks of rigorous training program called snow and ice acclimatization training at Oli and Mana in Himalayas. So there is a glacier called Satopanch Glacier in Upper Himalayas, where we undertook 3 weeks of the rigorous training, which reminded me of my time with school, Parity Scouts and Guides. So I was part of the Parity Scouts. So it is something like that. It's all about the survival. The key message in that camp is the same key message which I learned in school, in Scouts. They are, be prepared to face any eventualities. So proactive is much better than reactive. So expect the worst. In Antarctica, it's like it's a uh, white linen bed sheet, isn't it? Complete white, everything is white. So is it really easy to walk in Antarctic ice? Yeah, it is. I was thinking like the ice is something like very, very smooth ice, that it is very slippery. It's not. It's something like gravel. It's very easy to walk, but the catch is that Antarctica is like a minefield. If you ever walk on a minefield, you cannot even take a step without being cautious. There might be some mine waiting to get exploded when you set on foot, isn't it? That is why it's very dangerous to walk on a minefield. Antarctica is the same thing, because Antarctica is highly deceptive. You have no clue what lies underneath this ice sheet. There might be crevasse. Crevasse means hollow. On the top, it's only ice, but the ice is only like few millimeter thick. And the moment you set your foot on that ice, it can break, and immediately you are down the crevasse around 500 meter, half a kilometer, sudden death. You know, so you have to be prepared. So one of the key message which we learned in this training is never walk alone. You have to walk in at least three people, and each three people should be tied with a rope. The reason is simple, that if one person falls down, other two can at least try to rescue that person, you know. Yeah, I just want to make sure that everybody is listening and my voice is clear.
Yes, sir. You're
All
audible.
right, good. Yeah, so and in November 2016 I got the passport. So you might wonder, well, I've been to all these countries, 22 countries earlier, and didn't have any passport. One second. Okay. Yes, I have the passport. So that passport is, the normal passport, the personal passport. That is insufficient for going to Antarctica, friends. In Antarctica, there is no tourism. So you have to be part of the government mission to go to Antarctica. So the normal passport that you have, you cannot go there. You need official passport of the government of India. That is the white passport. So to get this white passport itself is a privilege. You need to apply for it, and your name has to be approved by President of India. And once you have this official passport, you can go anywhere in the world without visa. See, that's a huge privilege. And I have this passport, but that got cancelled after my trip to Antarctica. That is the official way. I have to get it cancelled because that passport is only for this kind of national missions. And then finally I went to Antarctica all the way on 19th of December. So it's, it is quite boring trip, all the way to the southern tip of Africa by air. So I never liked the air journey. Air journey is very boring, people simply sleep in. But the excitement started from this trip, from the Cape Town, because we went in ship. So this is the team in the ship that we went in. You can see that many girls are there. And I'm really excited that I'm giving this talk in Carmel College for women. So, as a woman, don't be afraid. You can go to Antarctica alone. Many of these are students, these two are actually the students from different organizations in India, and this lady is basically a doctor, an MD doctor. She's a DM basically. And I asked her why you applied for this trip, because she said that she read a lot about Antarctica and it's her life dream to be part of the Indian Antarctic mission. So that is one thing binding all of us, that going to Antarctica is like a life's dream. We really wanted to go there, and that is why we applied. We actively pursued our dream. You can also do it, right? So that's how the Antarctic trip is. So and then we went from Cape Town to Antarctica by icebreaker, and we have seen all these, we crossed all these famous, or rather notorious, horse latitudes. You might have read about this in the trade winds in geography in school. Roaring 40s, 40-degree easterly, then westerly furious 50s, then easterly screaming 60s, and then westerly, Antarctic westerly, right? So all these trade winds you cross, and then you reach near Antarctica, but then you reach Antarctica and then you have to cross the continent Antarctica is all ice. That is basically a continent, and if you drill underneath is rock, you know, and that ice is approximately 4 kilometers in thick, right? So this is how we actually go in, and yes, so this is a teamwork. That is what I would like to emphasize. If you think that okay, you're a professor and I will do only research, you cannot go there. You need to multitask. Like here, I was appointed with this particular job of transferring the fuel. The fuel that we use is not diesel or petrol. We use jet propulsion fuel number 8. So this aviation fuel, the same fuel that the jet, the airplanes use it. You might wonder why. What's the problem if you use normal diesel or petrol? Because of the freezing point is very high. So you need a very low freezing point, because in Antarctica it's really cold, right? And that is why it's jet propulsion fuel. So all the kind of work, this is galley duty in the kitchen of the ship. We used to do that, right? And yeah, so it was very exciting. Whenever we are free, we go to the deck to take some photograph. This is the Royal Albatross, this is the snow petrel, squaw, and so many of these kind of interesting and bizarre physical phenomena which I saw. Many of these I have written about it, the Popular Science article. For example, there is an article which I published in Science Reporter about physical spectacles of Antarctica, in which I wrote about this phenomenon, green flash. And this was the last sunset which I ever saw. And after this day, we were already crossed Antarctic 66 degrees south latitude, and it was austral summers. 24-hour summer. Yes, 24 hours sunlight. So like in the midday, 12 o'clock in the noon and 12 o'clock at the night, intensity of sun is same, but it never comes on the top of your head. It's always just go in circle at the horizon. So that is why it's very, very cold. It's very weak. So just after sunset, you can see a kind of a green flash emanating at the horizon. So that is the reason is basically the reflection and scattering of the sunlight. So this is actually happening everywhere, but it's visible only in near Antarctica. The green flash. And this is the bridge of the ship. So the bridge is something like the. Oh, give me a second. I'm getting some call. Hello. I hope I'm audible.
Yes, sir.
Okay, so this is bridge. It's something like cockpit of the airplane, in which the captain of the ship is steering the ship. So how the ship is getting steered. So I'm sure people know a little bit about it, because you're in Goa, the place of the ports and ships. So there is a very important equipment here called sonar, and the principle of sonar is quite similar to the principle of the ultrasonography. Especially the pregnant ladies do that ultrasound to visualize the womb, isn't it? The fetus. Or how the bats navigate. So every field is interconnected. That's the beauty of science. If you know the objective truth, then you can apply the same principle across the discipline. One good example is MRI scan. You go to a big hospital, there are MRI, but the real MRI is invented by physics, who never thought that it has an application in medical field. So it's very interesting that the right here is our shape, and all these dots you see, that yellow dots, these are huge ice, the icebergs. And in case the ship hits on the iceberg, then the ship will be completely devastated, like what happened to the Titanic. So you have to uh, carefully navigate using the sonar. It has got transmitter and transducer to range, something like the radar as well, So that is how the hull of the ship, and glacial blue ice. The ice is quite bluish in color in Antarctica because of the stretched OH bond that absorbs the opposite of the blue spectrum, that is basically the red color, you know and that is the reason why it's actually the blue color. And why it is getting stretched? Because of the extreme hydrostatic pressure. In Antarctica, it's around 4 kilometer of the thickness of the ice, and because of that is extreme pressure. And I'll just flash through some of the images. This is the ice breaking. We just smash on the ice sheet, and then we reverse sail and again smash. That is how we break the ice. And this is only pack ice, you can see, but at the horizon you can see the continent of Antarctica that you cannot break. It's 4 kilometer thick ice, right? So the ship will be anchored near the Antarctica. And on the way we saw so many interesting scenes. Finally, we are in Parity Station. This is one of the latest Antarctic station. The whole station was built in Germany, disassembled in Germany, and then reassembled. And that is why we have a German flag, this right in front of Parity. We also have flag of the Russia. Right, 1 second, please. Yes. Yeah, so you can see so many flags. Of course, this is our tricolor national flag of India, and you can see what are these flags then? You might wonder. This is the flag of Australia, because Australian station Davis is very near to our own station. So we have all this communication between the station. You don't need any visa to go, we are all friends. And you can go to their station, and you can help each other in case of medical emergency, all those things, right? You can also do the research together, internationally collaborative research you can do. And this is the German flag because the German engineers are residing. It's basically the station is built in Germany, and then it's maintained by the German team. And this is the Russian, because the ship that we took is a Russian ship. So the Russian help is really important and much appreciated. And also the Russia also had we had one helicopter of the Russia here. So 1 second. Yeah, so yes, Russia is also very crucial because first of all we took the ship. Second is that the helicopter, Kamov helicopter, and the crew. We had two helicopters in the ship. So one is of the Russia, another one is of the South Africa, and that is why we also had the South African flag in front of the Parity station. So the whole station is made out of the these shipping containers. So if you have ever went to Vasco port, the port of Vasco, then you can see that huge ship, right, anchored over there, the container ships. So those containers are standard dimension, and this entire station is made out of it. And it's really beautiful, and it has got some basic lab facility, including the laminar hood, you can see, and the humidifier, dehumidifier, and also some PCR machine it has got. Going back, you can see that autoclave, some kind of, and this is a tabletop centrifuge. This is milliQ reference water supply unit. So you can also do some bacteriological culture studies, right? And we also have got incubators, thermos, very good incubators we have. We also have several of the microscopes, even including the fluorescence microscope is there in that particular station, Parity station, And yes, so penguins and different kinds of penguins, Adelie penguins and emperor penguins. And yeah, so this is seal. It's basically the mammal. The only mammal that you can see in Antarctica is seal, two species, elephant and leopard seal. The photo here is leopard seal. It's very good swimmer too. It can dive really uh, below approximately 300 meters. It's a super good diver. And yeah, so this is how we used to dress. The it is basically around 6 layers of the dress, one on the top of one, because it's extreme cold, -79 degrees. On my right hand, you can see this is a probing stick to make sure that it's safe to set foot. I told you Antarctica is something like a minefield. And on my left hand, you can see this is basically the ice axe. So in case I fall down, I can try to escape myself by that. you know and also complete dress has to be UV resistant, because Antarctica, on the top of Antarctica, there is a the hole of the ozone layer, which is increasing now. The entire Antarctica is underneath the ozone hole, so UV radiance is very high. you know and we used to travel in one place to another by piston bully, and also skidoo, the snow scooter, and also by this helicopter. This is Airbus helicopter. So this is how we used to travel in the continent. And this is another of the helicopter, that is camo. And this one is the skidoo. This is basically the scooter, the snow scooter, in which you can go to small distances, even up to 20 kilometers you can go. And what did we do? This is hand auger to drill a hole. So the drill, the hole, if you look at the hole underneath the ice sheet, is blue color. So I told you it's glacial blue because of the OH stretch. And the scientists, we recover this core of the ice. And why do we need this ice core? I don't know how many of you know that these are the most important crucial windows to the past climatology of Earth, planet Earth, for like millions of years back, how the Earth had been. To know that, you just need to drill the ice. And if you drill the ice, I told you the Antarctic ice sheet is approximately 4 kilometers in thick. So it can go really deep and retrieve the ice. And once you retrieve that ice, inside ice, you can see this sort of small bubbles. And these are nothing but air bubbles. So these are trapped air. And this got trapped when the Antarctica was found millions of years back. So as deep you go, as old it gets. The bubbles, it gets really old. So really deep, like 4 kilometers underneath this ice, if you retrieve this kind of ice core, and then you aspirate with a fine needle, like biopsy, the cancer detection biopsy, right? The fine needle aspiration. So you take out this fine needle and aspirate the air, and then you inject this air into an instrument called gas chromatography mass spectrum. So then the instrument will tell you how much is the CO2 level. Yes, now you know that around 100 million years back, how much was our CO2 level. And you can do a gradation till now by going depth-wise, so decreasing the depth means it gets younger, right? So that is how we now know that the CO2 level right now, it is around 400 ppm. So it is really large. And early on, it was much lower. So the CO2 level is spiking. And this spike is recent. In the last 3-4 centuries it happened. So it is correlated with industrial activity and coal burning, fossil fuel burning. So that kind of paleoclimatology, you can do that with the ice core studies. That's really, really important. And this ice core is not just for the CO2, but also for the oxygen isotope ratio. If you look at the oxygen isotope ratio, you can even predict the temperature when this ice was formed. So that way you can do a lot of interesting studies. So so there is these are lakes of the Antarctica, and these are nothing but cyanobacterial film. So biofilms of the cyanobacteria, and the bubbles, you can see the same bubble which I already explained to you. And this is how you core it, right? This is one of the famous station. The Antarctic station is called Vostok station. So underneath you can drill it. So this is a very, very important ice core, Vostok ice core. And if you go really deep, it becomes really old, the trapped ice. And what lies underneath the ice sheet of the Antarctica, which is approximately 4 kilometers in thick? There are lakes, subglacial lakes, and these lakes are not frozen. Reason is that it is in touch with bedrock, in congruence with bedrock, and the rocks are always hot because of geothermal effect. And that is the reason that lakes are not frozen. And between these two, three lakes, there are, connection, there are conduits, so-called secret rivers of Antarctica. River is always flowing downstream, isn't it? So that is the kind of uh, the canonical image of the river that might come to your mind. It will be coming from the mountains and all the way to the sea, right downwards. But in Antarctica, it can even go uphill. That's very interesting because of the hydrostatic pressure, and there are volcanoes underneath the ice. I mean, it's very interesting. And the Antarctica is something like Mars, or exoplanets. So that is where a lot of exobiological research is happening in Antarctica. There are ice caves in Antarctica, really deep blue ice caves, and Adelie penguins, and all these are emperor penguins. And this is called waddle of penguin. A group of penguin is known as waddle, right? And there are penguin rockeries where I found, this is my own pick. All these picks are mine, And this is a pick from helicopter reconnaissance. Around 10,000 or more penguins. This is another kind of penguin called chin strap penguin, very beautiful chin strap. And this is squaw, this is petrel, this is a snow petrel, this is storm petrel, elephant seal. And then we left this station and we went westward. From this eastward to the westward, we went to Parity Station, around 3,500 kilometers. On the way, we saw orca, the killer whales, you know. And yeah, so, Antarctica, another very interesting speciality is that in, the time zones of the world is, if you look at the world globe, there are two kinds of line, right? One is called latitude, another is called longitude. So everything is, the time is determined by longitude, like prime meridian, the Greenwich meridian, right? In India, whatever the time that we follow. So all these longitudes converge in South Pole. Of course, it converges in North Pole as well. So that is why in Antarctica, if you go a little bit kilometer west to east or east to west, the time changes. Obviously the time changes there. So so that is why, like in the where we anchored the ship, we were following the Paris time or Berlin time. At the same time, at the station, we were following the London Greenwich time, only a few kilometers. So this is the station, Maitri station. This is a very old station, commissioned in 1988. you know so this is the station where I based at for a few months. So little bit of the pics from the Maitri station. There is not much of the research happening in the station, but it's something like a camping spot that we can spend our time over there. It's really old station. There is a small library, there's a small post office, very interesting. It's just a namesake post office, but whatever the things that you put in, we used to carry back, you know and the stamp in that, whatever the post is, this is something like an outpost of the North Goa post office. You're from Goa, so the same North Goa post office is like an outpost of it, Maitri post office. Everything is special in Antarctica, even its toilet. you know so the reason is that there are no decomposers, no decomposing bacteria in Antarctica. And because of that, what is happening is, in case you simply throw out your excrement, it stays there for millions of years. Even dead body never decomposes. So the two options, one option which we follow in Maitri station, very old system, is incinerate. So instead of flashing, you burn it. So that is the only option that is available. So of course, you're not burning every time, only like you're on duty. So I was on duty for many times. Give me a second. Yeah, so so this is old technology, but of course we used to do that weekly basis. It's again, this is a galley duty. We used to do that duty too. So you are burning, right? You're burning the excrement, though it is really not good for the continent, the pristine continent, isn't it? Because you're releasing the volatile organic carbon into its atmosphere. So latest technology that is followed in Parity Station, which is the new station, is We separate the excrement in the solid and liquid part, and the liquid part we actually try to decompose on our way back, and then we release it, in the ocean. That is the only option we have. But the solid part of the excrement, the stool, we bring back home here in India on the barrel. You know, so we used to carry the barrel on our back in the ship. I will never forget it. Sometimes the barrels are leaky, super stinky, but still we did that work. You know, so that is why if you have any caste feelings, you are not welcome to go to Antarctica. I was born in a Brahmin family. Actually, I changed my name though I haven't changed my religion. Yes, so so that is one of the question which I had to face during my interview, is that you should not have any feeling of the religion or caste. So you would need to touch others, and even the excrement, you might need to touch other excrement. So can you do that? Of course I can do it, because I'm going for a national mission. And that the feeling of nation and science above all should overpower you, rather than this kind of feelings of the religion or the caste. So we used to stay in this kind of hut, so this was the hut where I used to stay, and every morning it used to be full of snow, and we have to push it open, right? So these are nothing but the containers, the shipping containers. We changed this into the summer huts. And what did I do there in Antarctica, you might wonder. So this is one of the key discovery that I made, is that we discovered a new species of moss that is called Bryum paritiense. And this particular species, I'm sorry, I'm getting so many calls, 1 second now, please. Yes, and yeah, so this is it's basically moss, Bryum paritiense, and the name paritiense is because I got it in the vicinity of Parity Station, you know, and that was a first planned discovery in the last 40 years of Indian Antarctic mission. So that is why it came in the BBC as the title. You see, the India discovers new plant species in Antarctica. So it was a key discovery that our team has made. Of course, I collected the sample, but my team, my PhD students, did this work. You know, and yes, so the entire world media, including the UK's independence or Germany, Russia, everybody featured the story. And if you remember that early on, I spoke to you about my experience of the uh, Norway, right, in Tromso. I went in Tromso. Then I saw mosquitoes in Lofoten Island. You remember? So same thing here also. What is the biggest impact of this discovery is that it's yet another proof of greenifying Antarctica. Antarctica is now getting greenified because of the global warming. And there are so many evidences. One of the most famous evidence is by remote sensing by Dr. Matt Devey from Cambridge University. So he's remote sensing, that is satellite data, indicated that many of the algal blooms are getting more common in Antarctica. So ours is a ground validation. It's ours is not really the remote sensing, but it's actually the ground validation. We have the hard proof that the greenification of Antarctica is very common these days. So what is underneath the Antarctic ice sheet? That is yet another interesting question in the time of COVID-19. If you have read the Dan Brown's famous book Deception Point, which is rather a science fiction, similar theme was presented there, that with the with the glacial melting at Antarctica, whatever is there underneath the Antarctic ice sheet will come out. So it could be next coronavirus. The infectious diseases can come out. So such predicament cannot be avoided. So we have only one weapon to fight the climate change, by changing the lifestyle modifications. We can do it. And yeah, so it's not the time for blame gaming, or rather washing your hands and saying that okay, it's a responsibility of the government. No, not really. You can do some small change to your own lifestyle. Instead of traveling by car, why not cycle? And in this university, I'm the only professor who has no car. I don't care it. I don't know what others are saying about me, but why should I bother? Isn't it? I'm fine with riding my cycle. So as you, if I can do, why not you? And cycling is not just good for, for the environment, but also good for yourself. Your own life expectancy can be substantially increased if you cycle rather than if you go in on the car in car so this is same kind of thing what we can see that in one of the latest paper which I presented in curiosity. I have a science show in my channel, YouTube channel, so I do cover all these stories. So this is a very new story, it's published in July on 2021. So the Ohio State University, they drilled the ice core not in Antarctica but in Tibetan glacier ice. It's pretty near to where I'm living in Punjab. Himalayas are pretty close by. The team drilled there and they retrieved this ice core, same ice core which I have shown you, similar ice core. Then they actually did something called FACS, that is flow cytometry assisted cell sorting. And then they discovered viruses, 15,000 years old viruses discovered in the Tibetan glacier ice. And glaciers are retracting, glaciers are melting, right? And with the glacier melt, because of the global warming, these viruses get exposed. It gets released to the world. That we call it as new infectious diseases. You know, so that is exactly what is happening in the world now. You know, so other extremophiles which we saw in Antarctica, it's not just that moss alone, Mesotinium species. We also found Hemantothalus grandifolius and associated, the bacterial flora. Some of my PhD students are working on it. And the first report from Lasman Hills, Scalophilus astrosanguina is another seaweed, which is rather a red seaweed. Pink watermelon ice algae, Chlamydomonas nivalis, again the first report. And the same, ice algae, when you cultivate, this is the original spic, but when you cultivate, it changes the color into the green we are maintaining in the lab. So one of our key finding is the blood rain in Kerala actually, so that is basically Trentipolia orulata. Early on, people used to think that, okay, this blood rain is the aliens are responsible, but we shown that it is basically the Trentipolia. So similar kind of work that we are doing it. Photobionts of Antarctic lichens. The algal component of the lichens are photobiont. We are doing, some of my students are working on it. Braciola crispa from East Antarctica, the first report, it's basically the terrestrial algae, just got accepted, that paper. Epiphytic bacteria on Antarctic seaweeds, Eurospora species from Antarctic glaciers, Parmeria decipiens, lichen photobionts, different kinds of lichens and its photobionts, we are working on it, and Eurospora. So by the way, why you're interested in this biodiversity of Antarctica, this is, you might know this Gondwana, right? If you go back in time, there is, all the land masses were together, right? So it's called Gondwana, very big continent. So this is all about continental drift hypothesis, of Alfred Wegener, the famous German geologist. So if you look at that past map, the Antarctica and India was congruent, especially the east coast of India was touching the Antarctica. So even today, east coast of Antarctica and east coast of India, whatever the species that you see are quite similar, provided that the species split happened earlier than 200 million years back. So then it was then that the split really happens, no? So so 180 million years ago is the exact time the split happened of the Gondwana land during the Jurassic time. So if you look at like moss, in which most of the diversification happened in Carboniferous around 470 million years back, or green algae 1 billion years back, you will see similar connection, Eurospora. And also we also did some work on phytoplanktons. And finally comes the sunset, which we saw in the 21st of March. That is basically the equinox. So only on equinox you will see sunrise and sunset. That is another bizarre, isn't it? In Antarctica, there's only one sunrise per year in September equinox and one sunset per year. So 6 months is continuous summer, full-time light, and 6 month continuous winter, full-time dark. And during the sunset, you can see that there are two more sun left and right. This is called sun dog. Again, it's an optical illusion. And with the sunset, the continent is super good for astronomical observation. This is my own pick after the this particular event, the equinox. So this is our own galaxy, the Milky Way, and also it becomes conducive to see this kind of southern lights, aurora australis, so we can see this kind of different colors. It's like the dance of various colors in Antarctica. So finally we left, and then we came back home in India. So there is complete trip. So it's something like a virtual journey I took you all, and I hope I gave you a little bit of the inspiration of taking up this research as a career. And I wrote a book. You may order this book. So this book is basically Voyage to Antarctica. It's published by Government of India Press. And it's quite inexpensive, around 300 rupees. You can order through online. This is the website in which I have more detail and also some colorful pictures I've taken. So that's it, and I'm open for any questions if you have any. Thanks for having me here today.
So, we have a question by a third year student, Nifa.
Yes.
Could you tell us about the plant diversity in Antarctica?
So Antarctica is only for the so-called lower plants, but strictly speaking, I'm against this lower and higher. But yeah, so in Antarctica, you will not see any angiosperm except in the peninsula of the Antarctic. Antarctic Peninsula is like finger-like projection pointing towards South America, the Drake Passage. So only in that area, which is kind of a balmy area, warm area, you will see only 3 species of angiosperm. And of course, there is no gymnosperm. And in Antarctica, we will see mostly the plant diversity is algae on the coastline of Antarctica, and lichens you can see, and moss you can see in Antarctica. And our own experience said that how does the moss live in Antarctica? That is also a curiosity-driven question, because the moss need nitrogen. And the moss we saw moss only in the penguin rockeries, where you can see the penguins excrete, isn't it? Penguin guano. So basically it's getting the nutrition from the penguin's excrement. And how do we prove it? By looking at the isotope ratio, N15 to N14. N15 is a higher isotope. So if this N15 is more than N14, that means the source of nitrogen is from the animal. So that is how we knew that this particular moss is getting the nitrogen source from from the penguin. And moss, I told you. Lichens, I have shown you different kinds of lichens. And lichen, as it is, for the uninformed first year students, it is basically a symbiosis between fungus and algae, right? Algal component is called photobiont, while fungal component is microbiome. So it's basically you need 2 things, right, to form this lichens. So both are important, and more important is the algal component, because without algal component the lichens are completely gone, because algae is the one that photosynthesize. And without mycorrhizal component, can algal component survive? Yes, it can survive, because it is photosynthetic. And on the ice, the only plant that can grow is, again, I have shown you the picture. What is it? Anyone remember? On the ice, what can grow? Any students who remember what I covered in this today's talk? Chlamydomonas nivalis is one of the example of the ice algae. It is called pink snow algae or watermelon snow algae. And these are the only algae that can grow on the ice. Nothing else can grow. And we saw that the blooms of this Chlamydomonas nivalis, in which some areas of the glaciers are seen like blood color. And why it's pink or blood color, the red color? Because of the same pigment which is being expressed in response to the UV light. Pigment is called beta-carotene, the same pigment that we see that in carrots. That is where the name carotene, right? Carotenoid pyramid, pigments. And is it a good news? No, because algae is a living organism, and any living organism need liquid water for its survival. No, nothing can grow without the liquid water. So the algae, for it to live, it melt the ice. Exothermic metabolic reactions. That itself will lead to higher or accelerated glacial melting. Second, because the color has changed. On a hot summer's day, if you go out with an umbrella which is red, which is white umbrella, then white surfaces reflect the sunlight, isn't it? Most of the IR radiation, that is called albedo effect. So at the same time, you go out on a summer day with black umbrella, the normal umbrella, you might feel more hot and humid, isn't it? Because black surfaces absorbs the IR radiations. So it's preferable to wear light colored cloth during the summer and dark colored cloth during the winter. In South India, we don't have winter, but here in Punjab right now, we have winter here. Same thing happens in Antarctica too. This ice algae, because it changes the color from the white to watermelon or red color, it start absorbing more infrared, and that leads to accelerated the glacial melting because of this the anti-albedo effect. So yeah, that is another kind of the plant that you can see. And also terrestrial algae, which I have already shown you, Prasiola crispa, for example, or Eurospora, freshwater algae too. So other than these fern, for example, you cannot see in Antarctica. Yeah.
So there is another question on similar lines about microbial diversity in Antarctica.
Yeah, that's very interesting because Antarctica is a very extreme place. So only extremophiles can live, right? So the kind of bacteria that you can see here in India or anywhere in the world, you will not see that same bacteria over there. So only extreme, extreme microbes can live, especially the, that, what do you call this, archibacteria. So there is a lake near Parity Station that is called Deep Lake, near the Davis Station of Antarctica, right? So in that deep lake, you can see this, this bacterial community growing in, archibacterial community growing in that deep lake. And yes, so the the extremophiles only live in Antarctica, and that is the reason why decomposition doesn't happen over there. So that any cold place is the same condition, like in Everest, Mount Everest. Hikers knew it. So the places are named after the dead bodies. So dead bodies of hikers who lost their lives decades ago are still lying there in Mount Everest, and that is why some regions are called by the dead body names. So bacterial diversity is very interesting, and we never know that because of the extremophiles, what kind of unique metabolic pathways do they have, and what kind of unique biochemical compounds do they express. And that is why it's really interesting to check out. So one good example would be shrimp alkaline phosphatase, isolated from Antarctic shrimp. So exosap it is a very, very expensive biochemical, it's an enzyme which is often used in DNA barcoding studies. It's coming from Antarctic shrimp because of the a different kind of stress which they experience and different kinds of biochemicals they express in their system. And that is why it's a great avenue for potential bioprospecting, especially for in search of the drugs against various diseases like cancer.
So there is another question pertaining to the factors such as oxygen level, temperature, and UV radiation in Antarctica.
Yeah, so first of all, oxygen level. If you go in Himalayas, as you go up the altitude, then oxygen level is decreasing, isn't it? So that is the biggest difference between the acclimatization training that we had in the glacier in the Himalayas, Saturpanch, versus in Antarctica. So walking in the glaciers, I'm basically from the coastal region, like most of you. You're from Goa, the coastal cities. I'm from Kerala. So the coastal people like us, when we go in high range mountains like upper Himalayas, when you walk a little bit, you feel exhausted because oxygen level is very less. But in Antarctica, fortunately, that problem never happened to us because oxygen is as good. It's much higher. It is almost in the sea. At the sea level. It's nothing above sea level, approximately 60 meters only. So oxygen, there is no problem in Antarctica. It is as good as here anywhere, right? Second is second is temperature. Of course, it's very low temperature, minus 79 degrees. So it is something like that, like Europa or Enceladus. All these are moons of Titan and Saturn. So the climate over there is quite similar to the moons of these planets in our solar system, which is which is the active territory of exploration by exobiologists. So exobiology or cosmobiology is a discipline that is looking for the existence of extraterrestrial life. you know so that is why the climate is pretty near to the those kind of Enceladus or Titan or Europa. Yes, so it's very low temperature and high UV radiation. I already told you UV radiation is very high, and all because of the human efforts, the halogens, right? Chlorofluorocarbons. So if you actually bring the sustainability to your own lifestyle, you can fight all these problems with anthropogenic problems, including pollution, which also includes the UV, the ozone hole in Antarctica, as well as pollution by microplastics, you know, and also the global warming. Everything you can control by the way you're living in. For example, Down to Earth. I don't know how many of you know, there is a very nice magazine called Down to Earth. It's about the environmental magazine. It's all about environmental consciousness. So there has been an article in Down to Earth long back I read about Ludhiana here in Punjab, very near to the place where I live in. So there are canals in Ludhiana which is completely colored with dyes. It's a blue colored canals in Ludhiana. It's like heart wrenching scene if you ever go to Ludhiana. And why it is all dyes over there? Reason is that most of these jeans are being manufactured there, and there is an environmental cost, friends. You might be wearing jeans, trendy, fast fashion. You are paying a huge cost to the environment. You know, so I stopped wearing jeans the day I came across the repercussions of wearing jeans. So small changes that you can bring to your life can have tremendous impact on the life. So, and also for the climate as a whole. It's a shared responsibility for all of us. So we need to change the way that we think with we reconsider with our everyday decisions. For example, cycling. So here in India there is a status symbol, isn't it? So many of things that we take for granted are actually societal pressures. So one example is a cycle is good for school kids, and the moment you are in +2, it's time to get a scooty. And when you are in a college, or when you get your first job, especially, it's time to get a car. And when you get your promotion, then you need to upgrade your car from a small car to a big car, four-wheel drive. So that mentality, we need to change that mentality. 2019, I spent 3 months in a very prestigious institute, Max Planck Institute in Germany. The director of that institute was 35 years old lady. Can you ever think of it? Institute director is such a young lady. Leadership is again my favorite discipline. I really don't have time to talk about science leadership. Yes. And this lady used to come every day to that institute on her cycle. And behind her, there used to be trolley, in Germany or anywhere in abroad, you can see the cyclist do carry small trolley, separate trolley. And that trolley had her daughter, and she used to go to the nursery to send her to the school, preschool, and then come to the institute. And while going, she go to the nursery on her cycle, pick the daughter, and then go home. So if she can do it, why not us? The director of institute coming on a cycle. Can you ever imagine it? We need to change the way that we actually think of our lifestyle. Then we can fight the climate change.
Students, are there any more questions? I request Ms. Meena Miranda Verdes, Associate Professor and Head, Department of Botany, to kindly give the vote of thanks.
On behalf of the Department of Botany, it is my privilege to express a profound gratitude Bast, for readily accepting our invitation to deliver today's lecture. Thank you, sir, for taking a busy schedule to enlighten us with your experience. It's such a pleasure listening to the narration of your expedition, sir, supplemented with beautiful scenes, and more importantly, these in the research station, also your research. I'm sure our students have been enriched tremendously listening to you, sir, and inspired towards a scientific bent of mind. To our principal, Dr. Sister Maria Lizanne AC, for granting us permission to organize this lecture. Kim for coordinating this event so efficiently. I also thank my colleagues from the Department of Botany for all their help. To Mariston, Systems Administrator, for the
Thank you, sir.
support. Thank you for ending this lecture. Thank you.
Yeah, thank you so much, Dr. Meena Vedas and Dr. Kim Rodriguez for having me here, and enjoy the rest of the day. Goodbye.
Thank you, sir.